So in this lecture we will see that what are the limitations of propositional logic, and once we see the limitations of propositional logic, then we will get the intuition that why we need another language, and we will call that language as first order logic. Okay, so I think आप सभी को याद है कि जो हमने पढ़ा था कि there are three kind of languages. First language was our natural language, the second one was programming languages, and the third one was logic languages. So inside logic languages we first started about propositional logic, and now here we are going to see some limitations of propositional logic that further feels the necessity of introducing another language, and that is going to be our first order logic. Okay, so let us consider this statement: Alice and Bob knows arithmetic. So if we want to write it in propositional logic, हम इसे कैसे लिखेंगे? Alice knows arithmetic and then and Bob knows arithmetic. Okay, this is for when there are two persons. Now let us say we are having a statement like all students knows arithmetic. तो let us say the इसे लिखने का तो कोई तरीका हमारे पास नहीं है, बट लेट अस से इफ देयर आर गिवन 200 स्टूडेंट्स, all का मतलब है अगर 200 students are we are given the name of them, then I can write for Alice is a student. This implies that Alice knows arithmetic, and Bob is a student, Bob knows arithmetic, like this for all the students. So it is going to be cumbersome now, but even this is manageable. If you will see another example that is completely not possible to write, like every even integer greater than 2 is the sum of two primes. Okay, so this is our statement and we want to write it in propositional logic. Now see what is the problem here. Every even integer, so do you know how many, what is the count of even integers? It is infinite. Okay, so you cannot write this in propositional logic. This cannot be written, this can't be written via propositional logic. Okay, now see, so this cannot be written, so we will this makes the need for introducing a new language. Now I'm going to introduce one term, objects and predicates. Okay, objects and predicates. So what are they? Let us say you are having a statement like Alice knows and then arithmetic. So these two words, Alice and arithmetic, are these two words are objects. Okay, they are nothing but objects, and this thing knows, this is known as predicate. One thing I want you to be informed is that predicate logic means first order logic. Okay, they are synonymous, so it is same as saying first order logic. Okay, so now introducing the next thing, that is quantifiers. Okay, so what are quantifiers? Quantifiers, so when we talk about quantifiers, there are basically two type of quantifiers. First one is this and the second one is this. So this is known as universal quantifier. Universal quantifier, and I hope you have studied in mathematics, this is for all. This is basically for all, and this is existential quantifier. Existential quantifier, and this says there exists, right? Okay, so basically quantifiers are nothing. Quantifiers are a way of a way of saying there exists or for all. Okay, so they are basically a way of saying either there exists or for all. Right, so let us take this example. All students knows arithmetic. So how we are going to represent it in first order logic is for all, because it is all, then x, let us take a variable x, and then student x if x is a student. Okay, so what we mean is if x is a student, then for all x, it implies knows, and then what it knows x comma y, that means x knows y, so knows x comma arithmetic. Okay, so this is read like this: x knows arithmetic. Okay, so let us say you are having something written like this: moves to an x comma y. So basically this means x moves to y. Okay, this is just an example, right? So this was the FOL version. Okay, this is in FOL, first order logic. Right, now there are some terms in first order logic. Okay, and there are some like we saw in propositional logic, there were symbols, right? There were symbols, then there were connectives, symbols, formulas, connectives, etc. So on the same lines, in first order logic we are going to define something. The first one that I'm going to define is terms. So terms are nothing but expressions referring to objects. Example, there are three types: constant symbols, constant symbol, example Alice, then there can be variable, when this is x, and then function, so it can be sum of x and 3, right? Okay, so this is about terms. Now seeing the next thing, that is formula. Okay, so formulas, it is something like this: knows, let us say Bob, and arithmetic. Okay, so it gets applied basically, you know, it gets applied to a logic. So formula is a predicate that gets applied to a logic. Okay, then there are atomic formulas also. So atomic formula is a predicate that is applied to logic. Atomic means that further which it cannot be divided. Now in formula we are in atomic formulas. The concept is similar to the propositional logic. Okay, so now coming to the next thing, that is connectives. So you all know that what are connectives, right? On, and, or, negation, and then implies that, and then biconditional. Okay, so after this we are having, after connectives we have seen quantifiers. We have just seen what are quantifiers. Okay, now after seeing these things, I'm just going to discuss a bit about quantifiers. So what statement I'm making is universal quantifier universal quantifier, that is for all x or for all, is like conjunction. So why I am making this statement is, if I am writing, let us say if I am writing for all x px, okay, so basically this is like saying is like pa and pb and like this. Why? Because for all x, that means for all x p of x is true. So for all values of x, it may be a b c d like this, so everything should be true and therefore it should be and on the same lines we can write that the existential quantifiers, the existential quantifiers, that is this is nothing but disjunction. Okay, it is like disjunction. That means if I am having there exists x px, so it is nothing but it is like pa or pb or dot dot dot. Okay, one more thing that is very important is there exists y, and for all x knows x comma y is different from for all x and there exists y knows x comma y. Okay, so order should be the same. Here the order is different. Here the existential comes first and then universal comes. Here universal comes first and then existential comes. Okay, right. So now let us see some examples based on universal quantification. One point that I would like to make here is that whenever you are having if anything, अगर आपको इस पूरे लेक्चर से कुछ याद करना है तो one thing that you can remember is whenever you are having existential quantifiers, then implication will come. Okay, then implication will come once you are writing in first order logic, and if there is existential quantifiers, then there will be and. So this thing you must remember, these two things you must remember. Okay, so this will need this and this will need this will change to this. Now let us start with a question. The question states every student knows arithmetic. Okay, so there can be two ways in which we can write this, right? So the one can be for all x student x, and since there is for all, we should have implication as I said, and then knows x comma arithmetic. Okay, so this means that for all x if x is a student, then this implies that x knows arithmetic, right? Now the second method can be for all x student x and knows x comma arithmetic. Okay, so which one is correct? Which one is correct? Now see, we understood the meaning of this particular statement. ये हमने समझ लिया था कि this basically states that if x is a student, this implies that x knows arithmetic. And for this, the meaning is everyone is a student. Okay, everyone is a student, and everyone knows arithmetic. Right, so it says that everyone is a student and everyone knows arithmetic. That means knowing arithmetic is not dependent upon being a student. Okay, but what we had started with, every student knows arithmetic. That means if he is a student, then he should know arithmetic. So this is the correct choice. Okay, and this is the wrong choice, because it simply says that everyone knows arithmetic. It is not dependent upon the fact that he or she should be a student. So this is wrong. Also, in examination like condition, you check these things, that whether it is right or wrong, by checking that whether for universal quantifiers is a implication there. So here the implication is there, and that's why it is correct. Now let us move forward. Okay, so let us move forward and let us take one example of existential quantification. Existential quantification. Okay, so the example is some student knows arithmetic. Some student knows arithmetic. So I can write it like this. There exists some student x, और एक बार जब there exist आया तो there should be and. Okay, and then we should write the predicate knows x comma arithmetic. Okay, knows x comma arithmetic. Right. The second example that we will see is there is some course that every student has taken. There is some course, so obviously there will be an existential quantifier. So y and then course y. Okay, so if y is a course, then and if there is some course that every student has taken. So here we will write for all every student. So for all लगेगा for x student x, for all x student x, and takes x comma y, and from where the y is coming from here. Okay, so for all x, for all student, if x is a student, then he has taken the course y. Right, so this is the solution to this. Okay, so now in the next lecture we will see some more such examples of converting statements to first order logic. Okay, thank you.